Hi, welcome to another video tutorial on PumasCP. So in this data wrangling tutorials, we'll be looking at set operations that can be performed in the data wrangling wizard in PumasCP. So these set operations are key methods in data wrangling that help you to manage and organize your data effectively. Think of each dataset as a collection or a set of information. The set operations allow you to merge these sets together, find common data between them, and remove duplicates or unwanted information. These techniques are crucial for combining multiple sources of data, ensuring data uniqueness, and refining your datasets for analysis. By using set operations, you can streamline your data preparation process, making it easier to achieve accurate and meaningful analysis results. There are different types of set operations that you can perform: uh, concat, union, intersect, and except. Let's look at it one by one. Before that, I just wanted to introduce to the data set. Again, we have PC and EX here. I've performed some basic transformation that are ready to perform a set operation in the data wrangling wizard. Let's look at the basic transformation that I've performed. So you need to open the set operations study file and click on the edit option for the PC for set dataset. So in the PC for set dataset, I have created a column for ADTM, uh, converted the string variable in date to a date time variable. We all know how to do this use in the video that we watched uh, for derive related operations. So I use the datetime function to convert the PCDTC column to datetime, and then I have selected important columns, that is subject ID, domain, the concentration column, visit, and the ADTM column that I created in the previous step. The same way, let's click on cancel and go back to the study dashboard, click on EX for set and click edit over here. Here, the same procedure I have performed, created an ADTM and uh, selected important columns, subject ID, domain, dose, visit, and ADTM. So this is ready. Uh, these are ready datasets that can be used to perform the set operations. So what we'll do, we'll come back again, um, go to the PC for set dataset and click on edit. We'll continue the data transformations after the select function that we have performed here. So the first um, set operation is called concat. So to do that, click on the drop down in set over here and click on concat. The concat operation merges two or more datasets by lining them up one after the other based on the specified columns. So this is useful when you need to combine datasets end to end, creating a longer list of records. So for example, in this primary dataset, that is PC for set, um, and the secondary dataset that we have is EX for set, correct? So let's concatenate these two datasets, and uh, so the resulting dataset after concatenation will result in a single dataset where the records from EX for set, that is the EX dataset, follow those from the PC dataset. Here, if you observe, it has the PC dataset has 1536 rows and the EX dataset has 96 rows. So total we need to have 1632 rows once we combine these two or concatenate these two. So what we'll do is um, we will click on this drop down where we choose a secondary dataset and select EX for set. Yes. So here, if we observe, we had common columns, right? Like the subject ID, visit, and ADTM in both the data sets. So these are aligned and stacked vertically throughout the combined data set. And now let's organize this data by using the order by function. I'll click on order by and select the subject ID and as well as the ADTM column to sort it according to the date time. Let's scroll down and select ADTM. So this um, ordering of the combined data set by using subject ID and the date will organize the data so that the records from EX and PC are sequentially arranged. And this approach allows for a seamless integration of datasets, providing a continuous workflow of records based on the chosen columns. Next, we will look at the other operations in set. We'll just close this order by function and also the concat operation that we perform. So again, it's fresh to start with. Now, um, again, we'll go to set operations and choose union. So the union operation merges again two datasets into one, keeping only distinct records and common columns. To successfully perform a union, datasets should have the same columns. For example, unique columns like the concentration column over here, PC stress N, is it's just in the PC dataset, not in the EX dataset, right? Um, this should be excluded before we operate the union operation, or before we do the union. Uh, we need to exclude this uh, column PC stress N before we do the union operation. So let's just close this and then um, in the select columns, let's deselect PC stress and column as well. So that we'll have um, subject ID, domain, visit, and ADTM. And as well as what we need to do is we just click done over here and go to the EX dataset also. Because if you observe in the EX dataset, we have EX dose that is not common between both the datasets. So let's again select columns and deselect EX dose from this. So now we have uh, common columns in both the datasets. And again, we'll come back to the PC for set and click edit over here. And let's do a union operation now. Select set, click on union, choose the secondary dataset as EX for set. Yes. And um, the resulting dataset now, after the union operation, will have 1632 rows combining the unique records from both datasets. The common columns between the datasets are unified in the merged dataset. Now, I can again use the sort option or order by function, choose subject ID and ADTM to make sure I have the uh, records in an organized sequence. So this whole process effectively combines the data from both sources into a single set, ensuring no repetitions and maintaining the integrity of the common columns. You might also think, what if we had concentration and dose columns in the dataset, and if we do a union, what happens? To look at that, let's just cancel this order by function and also this union. And in the select columns, we'll go back and add the concentration column, that is PC stress N. And once the loading is complete, now perform a union operation again and click on union over here and select EX for set. Here you can see the error that that is displayed over here. The two provided tables have different sets of column names. The two provided tables in meaning PC and EX datasets. So that's the reason it's important to exclude those columns that are not common in both the datasets before performing a union. I'll close this union function over here and we'll go to the next set operation. So the next set operation is intersect, and before performing intersect again, we need to exclude common columns. So I added PC stress in the last step, right? So we'll click on the select columns drop down and deselect PC stress to make our data set ready for performing intersect operation. So this intersect operation finds and returns only the records that are common to both datasets, essentially filtering for exact matches across all rows. And this operation is useful for pinpointing the records that appear in both datasets, helping identify the shared data points. After excluding the unique columns like the concentration column, that is PC stress and from the PC dataset, and EX dose from the dataset, EX dose column from the EX dataset, any non-matching columns like domain uh, in both these data sets should be excluded. So we have uh, PC values in the domain column in the PC dataset. Same, we have EX values in the domain column in the EX dataset. So let's exclude that as well using the select function. I'll just scroll up and deselect domain over here. And the same way, we'll do that for the EX dataset as well. We click on done and move to the ex for set, click on edit, and here as well deselect domain, and the resulting dataset should have three columns: subject ID, visit, ADTM. Okay, and click on done. So we'll come back to the PC for set dataset, click on edit. Here as well we have three columns: use subject ID, visit, and the date column. So here let's click on set and then click on intersect now. We'll choose a secondary dataset as EX for set, and resulting dataset should have 24 rows. So this is let's look closely how what the intersect operation has performed. So in this case, the first record of the first visit is the only common entry across both datasets. And considering there are 24 subjects with 4 visits each, that is period 1 day 1, period 2 day 1, period 3 day 1, and period 4 day 1. These were the data in the visit column initially before we performed the intersect. And but in both the datasets, only period 1 day 1 was common. So that's the reason we see that across data sets what the common entry was only this. That's the reason this is being um the only the matching rows has been combined. And uh, as I was mentioning, there are 24 subjects with 4 visits each, and after performing the intersect, the resulting dataset will have 24 unique records that are common between both the two datasets. So if you want to look at what are the common data entries that I have in both these two datasets, then intersect is the best option. So it filters out all but the overlapping data, providing a dataset that consists of solely of records found in um, both of the original datasets that we have in hand. The last operation in intersect is accept. The accept operation identifies and returns records that are present in the primary dataset but absent in the secondary dataset, essentially filtering out the common elements. So again, this is just opposite of what intersect does. This function is useful for isolating unique records in one dataset or removing elements that are shared with another dataset. This operation acts as a converse of intersection, as I said, focusing on differences rather than commonalities. Again, here we have we need to have the common the non-matching columns. Like I said, the concentration x2 from the ex data set, everything should be removed, and even the domain column should be excluded, and it the except operation can be performed. So let me just cancel the intersect operation now here and choose except, and choose the secondary data set as ex for set. The resulting data set. So it should remove the remove the common rows or common entries. So in the previous operation, when we performed the intersect, we saw that there were 24 rows or 24 common entries between both the data sets. So when you exclude those 24 from the original data set had 1536 rows. So we just exclude 24 rows from that, and so these are unique to the primary data set. These rows that we see here, excluding the common elements found in the found in both the data sets that we see. So resulting data set will have 1512 rows, and this method effectively segregates the exclusive data of the primary dataset, providing a clear view of what is unique to it compared to the secondary dataset. I hope these set operations will be helpful for you. Uh, Thanks for watching.